Good morning, everyone. My name is Aladdin Shah. I am here to present my master thesis today regarding to improving the design of wind turbine plants. Before I talking about any improving, we have to look about the future of energy consumption. The future of energy consumption will be increased 56% in 2040. So that's why we have to provide more resource of the energy. Now, because this thesis is talking about the wind generating the energy from the wind, so we have to know what the evaluation about the global wind power. So as per the Stanford University, the evaluation of the wind turbines, the study said that 13% of the land around the world is windy. Windy, that means 6.9 meters by second it is. And the same study said that if we explore 20% of this 13%, we will get energy 7 times more than the world needs. So it's very good news for us to know that the wind evaluation is good and sufficient to take our requirement in the future. So what's the new idea is about, and how we can why the current design need to improve. The current design need to improve because of need to improve because of many points. Point number one, the wind speed. We need some flexible for our system. So the number two is we need to produce more clean energy. Number three, we need to exploiting existing technology. And the fourth one is to making the current design is over strong more than what we need. What are the new ideas about this one? If we're looking for this formula here, we see that there is 4 important values. The number one is the efficiency of the turbines itself, because we provide the proper generating to ensure that we have very good efficiency for our turbines. Number two, it is the density of the air when the air is getting colder and we have more power at itself. The number three, it is the swept area for the wind turbines plants. Number three is the wind velocity, which is very important for that, because if this value will be increased double, the power here will be increasing 8 times. So that's why the world years after years is coming and increasing the swept area and the hub high to get more energy years after years. And why needs the current design need to improve? Actually, the current design is good and producing more energy, but as per the humanity need and our mission in this plants to get more energy for our plants, clean energy for that. So we have to make our system is more flexible. How we make it flexible? By 3 ideas. The idea is number one, to increase the swept area during the wind low and medium velocity for the wind. Number two, providing hydraulic system. This hydraulic system will be increasing the hub height during the medium and low wind speed. Number three, providing new material, lighter and more stronger to build on larger or huge blades to make more, to capture more kinetic power from the wind itself. So if we're looking here for the general design for any blades, we can find that it is divided for 3 divisions. The important one here, it's the first third of this blade, because it's containing 50% of the mass itself. So this one is very strong and it is very important. Even in my design, I will the additional plates will be holded here or parking here during the normal operation system. The other 2/3 is very important for the aerodynamic forces, because when we go up here, the aerodynamic forces will be increasing. So this one, even the another value for this one is always is connecting and related to the length of the blade itself. So this is the new design. The new design is will hold new blades, extra blade. I will keep it here during the when the power reach the maximum. So we don't need to increase the swept area at all. So I will keep it here. But in some operation device, we will push it out by a flexible tube by pressure air. Why air? Because there is nothing more better than the air, lighter and stronger and faster. So we can easily to push out this the extra blade outside until the end here. And when we need to go back and reverse our procedure, just it is easy to use this wire, rubber wire, to pull down or to pull back the extra blades when we get the maximum blade. Now about the which generator, because as I mentioned before, the value number one, it is the efficiency for our. So we need to choose a proper generator for our system with higher, number one, with higher efficiency, number two, providing more power. So why are you choosing the direct drive synchronous generator, even the wound rotor synchronous generator, or permanent magnetic synchronous generator? Because this system is working without any gearbox. What's the mean gearbox? Without gearbox, it is easy to know that's gearbox. We reduce some mechanical compound connecting between the hub and the generator, so we have already increasing the efficiency, number one. Number two, we will reducing the weight of the nacelle itself. Number three, we will increase the probability for the system. Maybe it will something happen or any fault happen in the gearbox. So for three reasons, that the future system should be working without gearbox. Now about the hydraulic system. This is the hydraulic system. It is the section of the tower itself. It will contain two kinds of set: one run, one standby. It will be working pump number one with two hydraulic cylinder, for example, and the other pump with two cylinder will be standby. So it's this is one run, one standby to ensure that the system will be working always. And if anything happen for the first set, the second set will recover the system itself. So someone he told me maybe 100 ton. How we increase that? The consumption of energy will cut, and we will lose more money for that. No, we don't thinking about that, because we making some recovery system for the recovery power system for the itself. Because when the nacelle is increasing up by the hydraulic system, by gravity only, we can using gas pressure by gravity when take it down. Here, for example, this one, because in the first we give power, and the power will give us the flow to increasing the hub height. Here, the recovery system only, we will add in some component mechanical, like pressure valve or automatic valve to control the flow itself. Because this here will working as motor, here will working as the turbines or generator for that. But we have concerning about the flow. We have to control the flow to making the same rate at working same rate as turbine as the motor. Next now about the operation system. I have many ideas, the important things for any new ideas, how we operate this one together. As per my thesis, I'm making two options. Option number one, I'm making for to apply one of my ideas will increasing the smart variable hub height. So in option 1 we will use only the idea of variable hub height. Option 2 we will use two ones. I will increasing the hub height and I will increasing the swept area itself. So in general, any kind of option 1, option 2, we have two levels, level A, level B, and level C. Level A, it is the normal, there's no changing because the wind already, it is very high and we're reaching the optimal level of the power, so everything will keeping same. B and C, we will see what happened in B and C for every option for that. Now about option 1, level A, as I mentioned, that everything is same, original, nothing changed. Number B, when the wind here, because the wind here is very high, but when the wind is starting to decrease and the power is starting to decrease, so we will get help from the level number level B, and they switch on the hydraulic system to provide 30% hub high increasing, because we will get up two things, we will increasing of velocity of air and the density, because we will get up, we will be colder. So colder, this means the density of air will be higher. So this will help us to produce more energy. Number 3 here about level C, when it's coming down and the velocity of air coming below 10 meters per second, the system will active level C, which will reduce more 20%. We will taking total of 50% of the hub height for original system. So this is the option 1. Option 2 here, just we will keep in here, as I mentioned before, A is everything is the same, B everything is the same, only we keeping, but the level in C, when the velocity is coming below 10 meters per second, two things will happen. So we will we'll having increasing the hub height 50%, and the swept area will increasing 25%. So the both will be working. How it will be working? How it's convert that to numbers? It is here. Just here the operation of B from when the wind is between the above 10 meters per second until some reaching the optimal level. So this is B, and it is typical for option 1 and option 2. And we see that from the calculation that in future design will increasing the production 10% in this level of B. Level C, it is looking difference at all, because level A, option 1 and option 2, option N, when we increasing only 50% of the hub high, the future design will provide 16%. But the option 2 is so nice because we will be providing 46% from the total, up to 64% from the total energy. So this is the one, and we can have looked for the power curve for all the operation levels. So we see clearly that it's option 2 providing more electrical in the future. Now we're talking about if we convert this one to important value for any engineer, he will asking you what the capacitor factor for that turbines or for that location. Sorry. So option 1 will increasing the capacity factor from 36 and up to 38.5. But option 2 is very nice because it will increasing 36 to around 47% the capacity factor. So we have a big increasing of capacity factor. So now about the profit. Always we have to talking about the money, how much the profit we get it. So no problem for that because we calculated already. The total profit for option 1, it's almost the same. There is no change until the year number 11. After the year number 11, the future design is starting to slightly to increasing the money more than the conventional system or the current system. About the total profit for option 2, from year number 1, we starting increasing more money, and after 20 years we have a lot amount, and I think the investor will be so happy, and he is smiling all the time. So about the sound level, because the negative impact for any wind turbines, all the people is claiming when the noise we can't implement some. So we have to answer for this important question for that. Option one, it is logical because we not increasing the sweep area, only we increasing the hub height. So the nacelle will be more far away from us. So it's logical that the future design will provide more less noise from the turbine. But option two, because we increasing the sweep area itself, even we increasing the hub height, we will get in after 500 meters from the base of the wind turbine plants, the sound will increasing 4% for that. So about environment aspect. It is important because as renewable energy, we study to save the environment itself. So as I mentioned before, the noise level will be increasing 4%. And the number two is increasing the hub height. Maybe it will affect the immigration bird around the world. So we have to look and be more attention for the location we implement this idea. Number three, maybe because we're using the hydraulic lift system, some oil leakage happen, or during the operation maintenance, some thing having. So we doesn't prefer using in offshore because if the oil is coming for the ocean or the sea, it will make environment impact is not good. That's all. Thank you for all.
First of all, thank you for a very good presentation. Your thesis is very ambitious and have a lot of interesting ideas. However, it's very long, and you should maybe consider cutting it a bit shorter. For example, the background information regarding wind in the thesis is very extensive, and you already mentioned the most important parts in the introduction. Another thing I noticed is that you use very long sentences, which makes it kind of hard to read. So you should just consider cutting them shorter and not use so many commas. I also have a question about the hydraulic system. Have you calculated the energy needed in order to raise the hub height by 50%? Or did you just...
It depends on the weight of the nacelle. Here in my master thesis, I take some model numbers and I take it, the total nacelle weight is around 100 ton approximately for that. So it depends on the what's in the nacelle, which system we'll be using. For example, if we use the double feed or we're using the direct drive, which one? So the weight is different between model and other model.
Yeah, because the energy needed to raise it will kind of counteract the energy gained from raising it.
Yes, because...
But do you just count on like neglecting it because it generates...
No, the hydraulic system, I mentioned that the hydraulic system will not consumption more too much energy because there is a recovery power system. The recovery power system, when the nacelle is coming down by the gravity, we will take, this is the oil, pressurized oil for that, to using the pump for the turbine itself. And as I mentioned before, that's only we concern about the flow itself because the nacelle will very heavy and will coming so fast, so the flow will coming so high, so maybe will affect the turbine itself when it's working like turbines. Yes.
Yeah, yes. But how much of the energy needed to raise the hub height will be recovered?
Yes, exactly. Okay. As per the hydraulic system, on general, every ton is required 1.5 kilowatt. Yeah. Every ton to rise up this ton, we need 1.5 kilowatt by hour. Yeah. So we can calculate that's how what's the original height for that and how much will be rising, and it's easy to calculate that. But it is approximately because year after year the hydraulic system will be more efficiency. So 1.5 after 3 years maybe will come 1.1 or 1 kilowatt So it depends on the which model number, because I mentioned that I'm making quotation for 3 things from 3 countries, like Australia is very good quality, China is very cheap, for example. So it depends from where you're selling this, your hydraulic system.
Okay. I like how you explore many options for your design. It shows that you have put down a lot of effort into it. And regarding the extension of the blades, you mentioned that you are going to store the additional blades in the base of the blade.
Not the base, in the face tail of the blades.
Yes. And then you're going to extend it through the tip of the blade?
In the level C. I will extend it in the level C when the wind speed will be coming below than 10 meters per second. Yes.
Yeah, but wind turbine blades are twisted.
It is not twisted, because I mentioned that the current design is, when the engineering and construction engineering making this design, it's making to carry up to 33 meters per second for 10 minutes. So it's, when we're talking about 10 meters per second, it is light. Something you are so strong to carry 1 ton, but in additional it's easy to carry 100 ton in some way. So my idea is to exploiting that's over strong for our loads. So this one is working for the maximum, but the maximum is coming 5% during the year. So what will happen for that? So my idea is, okay, we have over strong for the construction, over strong for the tower itself, over strong for the blade. So we need to exploiting that strong some way. So that's why I focus on what's increasing the sweep area during when this increase the wind speed below 10 meters per second.
So your blades are not going to be twisted?
Of course not.
But you don't mention it in the report.
I mentioned in the report there are concerning for making something. That's why I suggest use new material as carbon nanotube, which nanotube is the NASA is making elevation from earth to the sky. I mentioned that. So I mentioned that with this idea and providing a new material strong. So if the current material is not that efficient, or it's not helping my idea, of course I will not use it.
Okay. Yes. Otherwise, it's good, but you use Wikipedia as a reference, and maybe you should do it.
It is not. I know that Wikipedia should be not mentioned for that, but Wikipedia for something like.
I know it was nothing important, but still.
Yes. And there's even Wikipedia. I make looking for the reference from which Wikipedia coming this from. So I ensure I taking this one, but also I consider that this information is right or wrong, and not put anything in my
Maybe you should reference the reference on Wikipedia where it's.
I'm not feeling good for that. From Wikipedia, I can't. So if someone he told you your information, you have to mention his name. Even he very strong, and he bring it from his professor. So you have to tell that. Alan, he told me something nice. He heard from Mr. Johnny. So I'm not feeling so good to do that. But it is easy to do it, but I not do it. Yes.
Okay, that's all. Thank you.
Well, it's open for you all to ask questions to Aladdin.
Yes.
Is there any possibility to upgrade the models that we have already installed?
Anything? Upgrading
the wind farms that are already installed and operating.
I concern about that because we will change the tower itself, and we providing I making excavation for the if we having extra oil, you have to make some excavation for the collection tank for the oil. If something happen, we can't drain that. That's for the drawing itself, and we need to provide.